Welcome to the new class. Today we're covering organic chemistry. The very first part of organic chemistry will be talking in general about what is the chemistry of compounds of carbon and what are the numbers of organic compounds. And you will be interested to know that this exceeds 8 million compounds, which makes it really, really difficult to know all of them. However, we'll try in this class to focus on the most important ones that are related to air pollution. Number of inorganic compounds is about 300,000, and this shows you the difference between organic versus inorganic. So how do we characterize the carbon atom? The atomic number of the carbon atom is 6. The atomic weight is 12. Total number of electrons, 6. Valence electrons are 4, which are the ones available for bonding. Forms of covalent bonds, you get single, double, and triple bonds. So the carbon atom can have with another carbon, it can have one bond, and that will be a single bond. It can have 2 bonds, if we add another one here, or can have also a triple bond, if we can add another one. What is the molecular structure and semi-structural formulas? The molecular formula is the one that we use all the time, similar to C2H6. But we can also write it in a structural formula where we can have the C showing the bond with another C and then showing how the C's are bonding with hydrogens and how the C is bonding with hydrogens. So this gives more information about the orientation of the orientation of the elements and the composition of our organic compound. Or you can get a semi-structural formula where you have CH3, which is, in this case, this will be, change the color, which will be this part and this part, where each, so CH3 and then another CH3, and that's a semi-structural formula. Hydrocarbons are compounds formed only from carbon and hydrogen. So it could be in the form of alkanes. Number 1, alkanes. Number 2, alkenes. Number 3, alkynes. And number 4, in cyclic compounds. And let's start with the first one, with the alkanes. Alkanes are carbon atoms linked only by a single bond. Remember when we talked about could have single, double, or triple bond? So the alkanes are actually having one bond, which means that the carbon atom always have 3 other bonds that it needs to have, because finally it needs to cover how many? It needs to cover 4 bonds for each carbon. So the most simple alkane will have C and another C and 1 bond. Now this needs to have 3. So in hydrocarbons, this will be 3 H's and this will be another 3 H's. Or it will have 3 C's. Each one will be connected with 1 single bond. And here we'll have 3 H's. Here we'll have 2 H's, and here we'll have another 3 H's. So this one, where we have 3 carbons, will be C3H, 1, 2, 3, 4, 5, 6, 7, 8. So will be C3H8, and in this case, it's called propane. If we have 4 carbons, then it will be C4H10, and it will be called butane. If you look at the names, they all ends in ane, which refers to the parent compound, which is again alkane. So that's why when we start with one, which is methane, two, ethane, propane, butane, pentane, and the general formula is CN, H will be 2N plus 2. Let's move to isomers. Isomers are compounds that have the exact same structure. However, they are oriented differently. They are organized differently. So, for example, when we say, look at the butane on the left, this butane is C4, and then we said that we have H10. However, you can have the same as C4, 1, 2, 3, and then you have the 4C here, and you have another H10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So both compounds are C4H10. However, what we can see from this one is that the N-butane is aliphatic, and aliphatic means that it goes like an aleph in one very long stick, and the other one is branched, meaning that it's not going in one line, but the second carbon is connected to one other carbon rather than going in a chain. So that we call I-butane. So isomers are compounds with the same molecular formulas, but with different structure. All alkanes with 4 or more carbons atoms exist as isomers. Alkanes with 5 or more carbons atoms exist as more than 2 isomers. So that will figure out the first one, which is alkane. Next will be alkene, and alkane has 1 bond, so alkene will have 2 bonds. Let's look at the alkenes. The alkenes get 2 bonds between the C's, so it will be have only 2 extra spaces for hydrogen. So in this case, we'll have 8 hydrogen here, and hydrogen here, hydrogen here. So it will be C2H4. And so in this case, the general formula is CnH2n, while in the alkane was CnH2n plus 2. So the smallest alkane is CH2, and it goes, that's methylene, it goes ethylene, propylene, butylene, pentylene, and you can see that the ene comes from the alkene. Similar that methane comes from alkane, methylene comes from alkene. So also there are compounds called olefin compounds, which consists of an olefin that has 2 double bonds, diene. The olefin is any of the class of unsaturated open chain hydrocarbon, such as ethylene, an alkene with only 1 carbon-carbon double bond. So the butadiene, which is C4H6, you can see that it's a very normal alkene, while the C5H8, which is the 2-methylbutadiene, has a methyl group that is also connected, methyl group over here, that is also connected to an alkene. Other butylene isomers include alpha butylene, trans beta butylene. The third one is alkyne. So alkane will have 1 bond, alkenes will have 2 bonds, the alkynes will have 3 bonds. So that leaves for the carbon only 1 more bond for hydrogen. The general formula for alkynes is CnH2n-2. And the alkynes cannot start with 1 carbon because if you have only one carbon, you cannot have one hydrogen present. So the smallest alkyne is ethine, which is C2H2, propyne, C3H4, butane, C4H6, pentyne, C5H8. The fourth type are cyclic compounds. Cyclic compounds are compounds that don't go in a chain or branched, but they actually go in a cycle. So the very beginning of the compound meets the very end of the compound and makes a cycle together. So similar to how we have alkanes, we can have cycloalkanes, which alkane meets its end, meets its front, also known as naphthenes. Cycloalkanes are monocyclic saturated hydrocarbons consisting only of hydrogen and carbon atoms arranged in a structure containing a single ring. All the carbon-carbon bonds are single. Cycloparaffins, 3 or more of the carbon atoms in each molecule are united in a ring structure, and each of the ring carbon atoms is joined to 2 hydrogen atoms or alkyl groups, which we'll talk about in a minute. Finally, aromatic hydrocarbons, that are the ones containing 1 or more benzene rings. And the benzene rings, these are very important for inorganic chemistry, and we'll talk about them in much more details. So let's look at examples of cycloparaffin compounds. So the cycloparaffin C3H6 was discovered in 1882 and was used as an anesthetic in 1933. It's extremely flammable and is thus no longer used clinically. Cyclobutane 6,4H8, also, although known for more than a century, their use as synthetic intermediate has only flourished in the last 40 years. Cyclopentane C5H10, preferred molecule for the manufacture of polyurethane insulation board as foaming material. Finally, cyclohexane is used to make nylon, used as paint remover. So that was the cycloparaffin. Now I told you, I'll talk to you about the benzene structure. This benzene is really interesting. So it was first discovered by the English scientist Michael Faraday in 1825, and August Kekuli visualized the ring structure benzene in 1865, and it's really complicated. So it starts with 6 carbon atoms. So the very first carbon and carbon. And let's take a look about how they are connected together. So the very first carbon has here 1 and has here another 1, but then they found only that this one is connected only to 1 H. Having this means that this carbon at one side needs to have a double bond and one side a single bond. So let's assume that the double bond is on this side. And then let's look at the next carbon. The next carbon also has 1 hydrogen. This makes the bond with the next carbon a single bond so that we can get our 4. Now let's look at the next one. It has a hydrogen as well, and 1 bond here. So this needs to be 2 bonds, and so on and so forth. I think you got the idea that it is 1 bond followed by a single bond going across a cyclic compound of 1, 2, 3, 4, 5, 6 carbons. So we can write it as, or put it as this here in 1. This is the structure as I just draw it for you, or easier as representation, we can put it as similar to the shape in number 2 or number 3. These are all representation of the benzene ring. So at one time, benzene was obtained almost entirely from coal tar. However, since 1950, it's replaced by petroleum-based processes. More than half of the benzene produced each year is converted to ethyl benzene, then to styrene, then to polystyrene. The next large use of benzene is in the preparation of phenol. Other uses include the preparation of aniline for dyes and dodecylbenzene for detergents. Biphenyl is a variation of the benzene ring. So basically, it is two benzene rings that are connected together. So instead of one H at the cycle, it's connected to another benzene ring. Biphenyl occur naturally in coal tar, crude oil, and natural gas. They appear as a clear, colorless, insoluble liquid with a pleasant odor. Their flash point is 180 Fahrenheit, and vapors are heavier than air. It is used to manufacture other chemicals and also as a fungicide, so basically killing fungus. In workers, acute short-term exposure to high levels of biphenyl has been observed to cause eye and skin irritation and toxic effects on liver and kidneys. The kidney effect have observed in chronically long-term exposed animals, and the EPA has classified biphenyl as group D, which is not classifiable as human carcinogen. Another compound that consists of a lot of benzene rings that are put together is benzoalpha-pyrene. This is 1, 2, 3, 4, 5 benzene rings together. The results of that is a result of incomplete combustion of organic material at temperatures between 300 and 600 Celsius. Can be found also in coal tar, tobacco smoke, and many foods, especially grilled meats. It is listed as a group 1 carcinogen. In the 18th century, a scrotal cancer of chimney sweepers, the chimney sweepers carcinoma, that was caused by the benzoalpha-pyrene. So let's really look at the nomenclature. I told you 1 is meth, 2 is eth, 3 is prop, 4 is bute, 5 pent, 6 hex, 7 hep, 8 oct. However, these are not really a language. Some people think it's Latin, some people think it's Greek. It's actually none of them. It is a mixture of names that chemists kept coming with. Found this as a fun fact. So the meth, for example, comes from methyl, which is in turn from the Greek word for wine because it smells like the smell of wine. Ethane from ethyl, and that a German chemist, put that name in 1834. Propane comes from propionic, which is in turn from pro and the Greek word for fat, so the smell of when you're burning fat. Butane comes from butyl, in which in turn from butyric. That's the Latin word for butter, so that smells like butter. So you can see that chemistry was actually more like called after the smells of foods rather than the food is called after the chemical compounds. So with this, we'll conclude the first part of this class. Next video, we'll be talking about different functional groups.